Let's create a unique product that truly benefits from 3D printing. Watch for keyboard shortcuts in the bottom left corner. First, we'll follow the first rule of Fusion, starting our design with a new component. Like many Fusion projects, this lampshade design starts with a sketch on the vertical construction plane. I'm using a fit point spline because it's a fast and flexible tool. Each sketch tool has its own strengths, so feel free to follow along and use splines, lines, arcs, or conic curves, whichever best suits your design. Your first sketch doesn't need to be perfect. Fusion's timeline makes it easy to update later. I'm setting the bottom radius to 25 mm, making the total diameter 50 mm. This is a small lampshade, but the key here is the workflow. Once you understand it, you can apply it to any dimensions for your 3D printing project. Adjusting the fit point spline is simple. Just move the black dots or tweak the green handles, but this will do for now. Since this spline is an open profile, you'll need to use the Surface Modeling Revolve command. The profile is already pre-selected, and having your design centered on the origin ensures the Z-axis aligns perfectly with the middle of your model. Setting the extend type to full isn't always necessary, but can have benefits when revolving 360 degrees. Once set, confirm the new body operation and you're good to go. The next sketch is simple but crucial for this project's success. We're using surface modeling to create two thin lines, which will generate two surfaces. These surfaces will then be used to split the body into 3 parts. The length of these lines doesn't matter, but I recommend making them extend beyond the surface body to allow for future adjustments. I'm using dimensions to set their distance from the top and bottom. These sections have different colors in the image at the start of this Fusion tutorial. Use the Surface Modeling Extrude command since we're working with open profiles. Set the direction to symmetric to capture both sides of the model. Again, oversketch your design to leave room for adjustments and avoid spending time perfecting unnecessary details. A quick visual check from different angles confirms everything is on track. The split body command is simple to use. 1 body to split and 2 splitting tools. The impact isn't immediately visible, but by clicking on the bodies and checking the project browser, we can see that there are now multiple bodies. 2 splitting tools and 3 parts from the original surface model. You can name your bodies for better organization, but I'm prioritizing speed here, so I'll move on. Next, we'll create a sketch as the foundation for the unique pattern we'll distribute around the walls. For a clearer view, turn off the visibility of your surface models and enable the first sketch. The fit point spline is perfect for this task. This time, I'll refine the curvature a bit more, but not too much. We need to see the 3D shape before deciding if the design works. I'm intentionally sketching this above the top of the vase as part of the over-sketching technique, where we extend sketches beyond the borders and use only what we need. I'll adjust the spline curvature so it straightens out at the end. The portion of the spline that extends above the long straight line at the top and below the long straight line at the bottom won't be part of the final design. You'll see why soon. I'll also adjust the top of the first sketch to create more space. The surface model updates instantly, a great example of how seamlessly the Fusion timeline handles changes. The surface extrude command allows us to create a thin surface, which will later thicken to perform an extrude intersect operation and generate the pattern. An alternative approach would be to use a closed sketch profile, but I prefer the flexibility that surface modeling offers for editing. We've created one curved shape and will mirror it to generate another. Any future adjustments to the fit point spline sketch will automatically update both the solid body and its mirrored copy. Once again, we're taking advantage of working at the center, right above the origin. While we typically use the Z-axis for circular patterns, we'll need a construction plane as the mirror plane, since an axis alone isn't a plane. I'm switching from a join operation to a new body operation, allowing us to keep them as separate bodies. This provides flexibility, such as assigning different appearances to each. We won't apply actual appearances to these solid bodies, even though the example is valid in other cases. Here, they're simply tools for the intersect operation on our next part. Since the top and bottom should remain solid without a pattern, we'll keep them hidden. Instead, we'll turn on the visibility of body 5, a part of the surface model. After performing the intersect operation, body 5 updates, leaving us with only the thin section we need, and it also generates a new surface model called body 9. For a more organized workflow, you can rename your bodies and sketches by double-clicking them in the project browser. You now have the 4 bodies needed to complete the design. The next step is to give them the desired thickness using the Thicken command. Since selecting them sequentially would cause Fusion to interpret the first selection as thickening toward the second, I'll thicken them one at a time. This process is quick, as Fusion suggests the previous thickness for new selections. You can also repeat the last action via the right-click menu. A quick quality check from different angles confirms everything is on track. To save time later, we'll apply appearances now while working with fewer bodies. Custom appearances let you apply colors beyond the default library. Start by choosing a base material like glossy or matte plastic, then apply any color. Right-click a color to enter custom RGB values, or click Advanced to use hex HTML codes, which are commonly used for precise colors. You'll find the custom color library a few steps below the top menu. Once you enter a hex code, the color updates instantly. There's no need to reapply the glossy plastic, just duplicate your selected color, enter a new HEX code, and apply it to the desired parts. You can find great color palettes online to enhance your design. For better organization, you can rename colors, but like with bodies earlier, I'll skip those details and focus on the overall workflow. I'll speed up the video for the final color since the process is the same. The workflow remains identical. I'll start by duplicating the color, then enter the hex code A8DADC and apply it to the bottom body of this 3D printable lampshade. Since we're done with the sketches for now, I'll hide them and minimize the project browser for a clearer view. This is a great time to save your project if you haven't recently, especially before adding a complex pattern. The circular pattern tool is intuitive, and you can select the bodies by dragging from right to left. The axis is already at the center of our design, and I encourage you to experiment with different quantities to create a unique look for your 3D print. I'll go with 12 for now. Before wrapping up this Fusion tutorial, I'll show you one final useful command. We'll pull the top of the vase to improve its ability to hang as a lamp. Keep in mind that this might affect the printability, but since materials, printers, and settings vary, you'll need to adjust the design to fit your specific setup. If you enjoyed this tutorial, I recommend checking out this one. I'd love to have you as a subscriber so I can keep delivering useful Fusion and 3D printing content here on YouTube. Happy 3D modeling and see you next time.